In this video, we will introduce binomial distribution and show how to draw binomial random numbers in Python. Binomial distribution is a probability distribution that summarizes the likelihood that a variable will take one of two independent values in a given set of parameters. And the distribution is obtained by performing a number of so-called Bernoulli trials. An experiment can be called a Bernoulli process if it has the following properties. First, the experiment consists of repeated trials. And second, each trial results in an outcome that may be classified as a success or a failure. So the result of a Bernoulli process is binary, yes or no, success or failure. And the probability of success, denoted by P, remains constant from trial to trial. And the repeated trials are independent, so which means each trial has no effect on the result of other trials in a total N trials. And the number X of successes in N Bernoulli trials is called a binomial random variable. And the probability distribution of this discrete random variable is called the binomial distribution. And its values will be denoted by B, X. X denotes this random number, N, P. N is total trials. P is probability of success in each trial. So for example, flipping a coin repeatedly is an example of a Bernoulli process. And the number of heads occurring among N times flipping follows a binomial distribution. So the formula to calculate the probability of random variable X, which means how many times of success will occur during the process of N trials, with the probability of P for the success for each trial is a combination of Nx times P X quotes and Q N minus X quotes, and Q equals 1 minus P. So X can be 0, 1, 2, 3 to N. And the mean and variance of the binomial distribution B, X, and P, mean equals N times P, and variance sigma square equals N times P times Q. So we will show how to work with binomial distribution in Python. In Python, the scipy.stats module contains various functions for statistical calculations and tests. And the stats function of the scipy.stats binom module can be used to calculate a binomial distribution using the values of N and P. So the syntax for this function is scipy.stats.binom.stats with NP for the parameter. And it will return a tuple containing the mean and the variance of the distribution in that order. So next example is calculating a distribution table. So we define N and P and define a list of values of R from 0 to N. Then we get the mean and the variance of this distribution. And for each R, we calculate the PMF and store in a list. PMF is the probability of binomial distribution for this random number. So we have to import import binom from this module. Then we set n equals 10, p 0.2 for each trial's success rate, and the total trials is 10. Then next, we define a list of integer number from 0 to n. Because success can occur 0 times, can occur 1 times, can occur 2 times, and so on, and at most occur n times of all n trials. So next we use the binom module's stats function to calculate the mean and the variance of this distribution. So the mean is 2, and the variance is 1.6. So this is actually the result of n times p. These two numbers multiplication will get 2 for the mean value, and n times p and times 0.8 equals 1.6 for the variance. And the scipy.stats binom.pmf function is used to obtain the probability mass function for a certain value of r and p. So we can obtain the distribution by passing all possible values of r possible from 0 to n. So the syntax for this function is scipy.stats.binom.pmf, and with r and p the parameters. So can calculate binom PMF for each value of r, calculate this probability, and put in a list. So if we show this list contains 10 numbers representing the probability of, for example, 0 times occur during 10 times trials is about 0.10, and 1 times occur success of all 10 times trials is about 0.26, and so on. The next we just print its values, print it out, and print mean and variance. Mean is 2, variance is about 1.6. So next example is showing plotting the graph using matplotlib, pyplot bar chart for a number of binomial random variables. So first we import binom and plot matplotlib pyplot function module. So this time we set large number with n equals 1000 trials, and the probability is same as before, 0.2 for success rate for each trial. And we define a list of integer from 0 to n. Next we calculate the probability for each random variable in this list, then put in a list same as before. So this list includes 1000 items. So next we show present in a bar chart of these 1000 probabilities associated with this random value. So it is clear that almost like a normal distribution is symmetric along for each side of the mean. Mean is about 200. Thanks for watching.